to the presentation. You have seen it's very easy to use, very fast to solve, because I need a fast tool. I don't need to spend a lot of time on the creation of the mesh or creation of the results. It's really a tool for the designer. And of course I can change it directly, the geometry, because I'm in SOLIDWORKS, and the recalculation is very easy. Okay, let's see also about kinematics, rigid body kinematics. Let's see this video. In this case, for example, okay. Okay, let's see. In this case, we have a medical couch, and we want to analyze which is the best situation for lifting this medical couch. Okay. Of course, we can add motors, we can add springs, dampers, and of course we will have all the results that are needed. Which kind of integration is with SOLIDWORKS? So we have the same user interface. We are just adding a motor, a linear motor, to the bottom of the mechanism, and we are using an oscillating device. Okay. So in this case, with the oscillating device, we can just calculate the simulation, the kinematics simulation. We can see if it's working and which is the extent of the leverages. Of course, later on we will see the results. So in this case, for example, we are seeing the results for linear acceleration. So, okay, here I've created a linear acceleration plot because I'm interested in which is the acceleration that is it's felt from the medical point of view. Of course, now we can change, we can have a design change because I am in the same environment with SOLIDWORKS. Sorry. So again, here I can have also other results as well as the motor force, because of course I'm imagining this mechanism, but I want to understand which is the engine that I have to buy to move this mechanism, this modern medical couch. And later on I will do some changes. Now you can see that I have added the force, the weight of the person that is on the medical couch, so I can evaluate again with just a matter of a click which is the actual level needed for lifting a person. Okay. Okay, so just to summarize, we have seen we can analyze motor, leverages, dampers, springs, and so on. We have results for displacement, acceleration, jerk. Of course, here I'm very limited in time, so I would like just to move on, but of course this is can be, let's say, focus of another webinar. Let's also get the job done from a fatigue point of view. Let's go back to SOLIDWORKS. Here, I would like just to evaluate, okay, here now I am safe with this design. The minimum is 2. The minimum factor of safety is 2. But I would like to understand from a fatigue point of view what is happening. It's just a matter of adding a new study, fatigue study. We can add an event, in this case 1 million of the static event. What does it mean? It means that I will try, let me draw it, I will try to understand okay. What is happening if I'm pulling and pushing this force back and forth 1 million of time? So it's not only about a static analysis, but in the time frame. So here I've loaded the event. I can define just the curve, and I can just run it. It's very quick. Okay, what you can see here, I can see that the damage is already at 100%. So it will not. This means that we will last 1 million of cycles. But I can see also the life. So I can understand. Let's put also the minimum here. Okay. So I can also evaluate which is the life. So the life in this case is about 50,000 cycles. So now I know that this kind of load can last only about 50,000 cycles. So this kind of load. Okay. So I have and it will fail near those 4 holes. Which is the hole that will fail? I don't know. But in this case, I have just an information to change my design. Okay, so very easy to use. Okay, let's go back here. And what is also the benefit is to have the SN curve of the material, and we have these curves available for all customers under subscription from Materiality web portal. And this portal is updated each month. So each month you will see an update of those materials. More or less, actually, we have something about 100 curves of fatigue inside the database, and more or less some near 1,000 of curves for stress strain, for nonlinear analysis. What we have saw also on the fatigue, it's extremely fast, because it's very simple calculation, but it's easy. It's also easy to use. We have just a static analysis, and we had added an event. Okay, and we can get damage and life plots. Let's check now what is inside Simulation Professional. Again, about Simulation Professional, I will not show everything. I will show something, let's say, from my point of view, valuable for the customers. But of course, all the modules are valuable, but maybe in specific situation. So I will try to cover the most important modules. The first one is about buckling and resonance. Why I'm putting together. Let's switch back to SOLIDWORKS. Okay, now I want to evaluate which is the buckling load factor. What does it mean? Let's go back to the static analysis. If I change now the direction of the force, now I will have a compressive force on the sheet metal. This compressive force can lead to let's say an instability of the material, okay, or let's say instability of the geometry, okay, not of the material. But I would like to understand which is the value of the instability. And this is linked also to resonance, because basically we are trying to understand which is the first resonant frequency and how much load is needed to put it at zero. Because if I use a compressive force, I will decrease the first resonance frequency. So it's connected. Okay, let's do it. Very simple. New study, buckling. Now the most interesting part, I can reuse all the stuff that I have here in the static analysis. So for example, the material, the fixture, the force, also the mesh, and I can just drag and drop into buckling and run. That's it. Very simple. Because basically I know everything about this. Let me put off this. Okay. I know everything about this setup, so I don't need to redo these kind of things. I can just import from another analysis. So what I see now, I can see what is the resultant compressive force, but not the stress, just the amplitude of the compressive force. And of course I can animate. So this is the instability due to the buckling. Okay. But also I would like to see which is the load factor. So in this case, let me zoom on it. I can show you this is the buckling load factor of safety in this case. Of course it's very high, okay, because we have a gasket here, so it's very difficult to make it unstable. But what I know now a factor to compare to the static analysis. So from the static analysis I've got 1.8 or 2. Now from buckling analysis I have 100. So for sure it will not fail for buckling. It will fail from static point of view. Okay? But in some situation, of course, it can be different. So I need this number to understand what is going on. And at the same time, I can have another study about frequency. And you will see in a moment it will be very similar. Again, here I can just reuse the part, the fixture. I don't want to use the force in this case, and the mesh. It's just a matter of dragging and dropping. And run it. You can see a very similar behavior, because this is connected. This is the first frequency mode shape, and it's connected to the buckling. Of course, here I can see also other one. For example, this is the second. Of course, I can expect to vibrate in another axis, and so on. Of course, I can calculate up to what is needed. 10 frequencies, 100 frequencies, 1000. What do you need? And of course, I can see the results in, for example, resonant frequencies. So this is the first frequency of resonance. Of course, I can see also a frequency response analysis. So these are the 5 frequencies I have calculated here.